Today, we're going to look at a linear relationship. We're going to use an example from a sample class. In a materials engineering class, the class will test how the materials react to stress. This measures the deformation of material every time additional stress is applied to it. So the result of the testing is shown on the table on the right. So we've got our information here. And our deformation test will tell us how much force is necessary to get some deformation on the materials that we're using. So this is a real world application that you may come across in, say, a materials engineering class. So the big question is, how can you express the relationship between the force and the amount of the deformation? That's our big question. To answer that question, we need to know a little bit about a linear relationship. We know that a linear relationship is characterized by an increase or a decrease of one variable as the other variable also changes. So when the variables are plotted in a graph, we see that a straight line is formed. So let's look at a linear relationship. Let's plot those values. So we have the variables that are plotted is 0, 2. You see you have 1, 3, 2, 4, and so on. So you are seeing that as force is being applied and it's getting larger, then the deformation that's happening on your material is also getting larger. We see that as you go up this line. So the variables form a straight line when it shows a linear relationship. Now, one thing we need to know about to be able to read linear relationships is we need to know which form the equations are going to be in. So they are going to be in slope-intercept form. So the equation of the line can be written using this formula. Y equals mx plus b, where slope is your m and b is your y-intercept. So let's remember, how do we calculate the slope of a line? Well, slope we know describes the steepness and the direction of a line, okay? It is calculated using rise over run, or the change in the y value over the change in the x value. Or another way to say that is you're taking your second coordinate point for y and subtracting the first coordinate point for y and dividing that by the second coordinate point for x minus the first coordinate point of x. So let's take a look at that. So let's calculate the slope of this line. One thing I want you to notice is they do have it labeled rise and run on your line. So one thing that we have talked about in class that we want to remember is you can find a rise over run using your slope triangle. But in this instance, the points do not land on a neat even grid line. So the numbers are going to be not whole numbers. So the slope triangle may not help us this time. We have to go back and fall back on our slope intercept form and specifically the rise over the run. So we find the y2 value, which is 6.38, minus the y1 value, which is 4.32. Now we got this information from the chart and from the table. And it's over or divided by the x2 value, which was 3, minus the y2 value. I'm sorry, the x1 value, which was 2. And once you subtract this and divide, you're going to end up with a slope of 2.06. Now, the other thing that we need to write an equation of a line was the y-intercept. So how do we do that? So we know that we can find the y-intercept because it is the point where the graph crosses the y-axis. Remember, we can calculate the y-intercept by determining the value of y when x is 0. So we can substitute some values to find the y-intercept as well, instead of just looking at a graph where we can see that x is 0, and then we can see specifically where y crosses, or the line crosses the y-axis to get the y-intercept. So we're going to substitute some values. So we have the slope of 2 6/100, and we have one data point. We have the data point of 1.0 and 2 26/100. Okay, now we're going to solve for y. So we take the entire slope-intercept form equation, y equals mx plus b. We know the y value from our data point, so we plug that number in, equals our slope. We know that, we just found it on the previous slide, and times x, which our x value is 1.00 from our data point, plus b. So we don't know the answer to b yet, and that is the only variable in this equation that we don't know. So using your steps to solve equations, you can isolate b on the left-hand side of your equation, and then you're going to be left with 2 26/100 minus 2 6/100, which would leave you 2/10 as being your y value. I'm sorry, your y-intercept value, right? So where is it going to intercept the line at? On the y-axis, it's going to intercept or cross that y-axis at 2/10. So we see that here. We see that our points are labeled on our linear relationship line, or our linear line. And we see that our y-intercept is going to be at 2/10, and we see that right here. Now that we know everything, let's think about our equation of the line, because we're going to have to write that. So remember that equations of the line, the two variables have a linear relationship. So it has to be a straight line for this to work. And as the force increases, as you're moving up or over on your x-axis, the deformation also increases, because we see that it's also moving up on the y-axis. So we used all the information we got, and we were able to double check our line. And so thanks for listening. So this was a quick recap of how to find and know what a linear relationship is. And I'll see you next time.